on my next slide? What do I want to say next? Okay, so and then what I want to say next about this, I'm going to give you some definitions of B and C. So let's go ahead and write the virial equation of state again. PVM equals RT. Let's start that again here. Okay. PVM equals RT 1 plus, and I'm just going to write this in terms of VM, but we recognize we can do coordinate transformation and make this a function of P and T if we want. Okay, C over VM squared, etc. Okay, so what we're going to do in the coming slides is show that B, this virial coefficient B, is equal to little b minus A over RT. And yes, those A and B's are the van der Waals coefficients. Let's change the color. Okay. So these are our van der Waals coefficients. Okay. So we can calculate these B terms. So these are specific for a gas, right? Because it depends on what type of intermolecular forces they have available. And the C term up here is equal to B squared. And yes, that's the same B in the van der Waals coefficient. Okay. And so let's see here. What else can I say about this? So you kind of saw typical values for A and B from that previous slide, if you recall. So B is always about 10 to the minus 2 liter per mole, and A is, you know, in the vicinity between 1 and 10 atm liter squared per mole squared. And so what that means is this A term really can dominate. Okay, so for example, we notice here that this C, right, in this equation is B squared. And if B is 10 to the minus 2 and then I square it, that makes that term pretty small. So that's why this C term doesn't really start taking effect until you get to fairly large pressures, right? So you can see at this Boyle temperature, you know, in this region right here, this is really corresponding to B equal to 0, right? So, as you might guess, if we know B equals 0 for an ideal gas, and that corresponds to the Boyle temperature, what's the equation for the Boyle temperature? Okay, pause the video right here, just see if you can think about it for a second. I'm going to move on and write that up. Okay, so at the Boyle temperature, this B equals 0. I'm gonna show in the next lecture video, because it's kind of a lengthy derivation. Yay, third video, lengthy derivations. I know you guys love it. B minus A over RT. Okay, so now I can do some algebra and solve for T. I would encourage you to do that. Okay, pause the video and do that. Otherwise, you can watch me do some algebra and get the answer, okay? So that's A over RT equals B, and then flip the position of T. And so now that's T is going to equal A over BR. So again, this is another kind of cool thing in PChem, right? We, like all of these fundamental constants, A, B, and R, we combine them and we get to something specific. Very cool stuff, okay? And so I'm gonna have you in the next exercise calculate this stuff, and I'm also gonna do a derivation, but I think I'm gonna save that for the next video, which will be a short video, and it'll be the last one for this week. Okay, folks. I'll see you later.